At this point, let's break and open the floor for questions. I'm sure you have questions for Grace and JD and James and Miko as well. I see that the group chat there have been questions from Leo and everyone else specific to the speakers, but this is our chance to ask them personally through our meeting. You can raise your hand if you have a question. Bayani, do you have any questions to our speakers, not to start our Q&A?
Sure. So maganda siguro magtanong muna yung audience, CP, but I do have some questions. Some are loaded. Sabi ni CP, pahirapan ko kayo eh.
Hindi. Ako marami rin akong questions.
Problema, you know, I know enough to be dangerous. I don't know any of
No.
So maybe for the next few seconds, baka may gusto mag-jump in, but otherwise,
Yeah.
and I will get the ball rolling.
I actually have questions to Dr. Betch and Dr. Yumul about the geochem of Miko. Baka gusto yung sagutin why it's not plotting in the usual fields. Ako naman, I'm sure si Dr. Aurelio has questions to Grace. Pero Grace, ang tanong ko sa iyo, you mentioned that the dike went up to the surface almost just 300 meters beneath the surface. Is that correct? So it means that we are that close of having magma, lava, coming out of that fracture, 300 meters, and it could have been more devastating if it did happen. Okay.
Exactly. That's true. Well, that's what the model says, of course.
Okay, that is quite too close for comfort, I think. Sige, Bayani, go ahead.
Yeah, so I have questions for everybody, but since sinimula mo na kay Grace, follow up ko na, tapos balik tayo kay JD. Pareho din naman silang remote sensors sa ngayon. So Grace, yung magma chamber na minodel mo, that seems consistent with what we know about volcanoes, the typical size. And you know, I'm a hydrologist, so I don't know anything about this. But the dike seems big. Just instinctively. Is that typical, or is that something that you think is, on the upper ranges or even beyond what we normally see as dikes for active volcanoes?
So, yung mga dikes na kagaya nito, actually, if you know the Barbabunga eruption in Iceland, almost same yung volume na in-erupt ng eruption na yun. And it also produced a large dike. Pero yung case na yun, nagkaroon ng eruption, and for Taal, hindi. So this case sa Taal is really very interesting, and we still do not know bakit hindi nag-erupt except for pressure-related kind of reason. So it's not really...
Baka nakuha sa dasal.
Well, one hypothesis that we had is because of the pre-existing fault there. So
but
it's also
the dike is aligned along.
Yes.
The dike is aligned along the Makulod corridor, di ba? Ganun yung alignment ng Makulod corridor itself.
Yes. So the role of the Makulod corridor basically really played well in this case, and it sort of relieved the pressure. So the dike may have erupted, but then because of the pressure release, it did not.
Actually, Grace, the dike and Bayani, the dike lines up really well with the trace of the West Valley Fault. Dr. Aurelio, correct mo na lang ako. If you extend the West Valley Fault down to Taal, that is the orientation. Or si JD, alam niya yata ito eh. Wala lang nagsasabi na hanggang Taal lang West Valley Fault. Dr. Aurelio, alam mo ba yun?
Well, I think the orientation of the dike is a bit different compared to the West Valley Fault. But I would be interested to see if the supposed drifting of the Makulod corridor and the dike are things that you could distinguish from the modeling, I guess. I wonder. But
So mapunta tayo kay JD dahil siya na nagsasalita. So JD, since you have similar data, the interesting thing about this data is you see everything everywhere, right? So it's overwhelming. It's different to what Miko was finding where, there's strips. So looking at Leyte, was there anything that was surprising beyond the fault? Because your model focused on the fault. You looked at locked parts of the fault and where there's creep. But what about the rest of the island? Was there surprising deformation in other parts of the island from your INSAR maps?
Yeah, so actually, I didn't have time to talk about its presentation, but part of our modeling, from the INSAR, we see the subsidence or subsidence happening in the geothermal area. And we actually tried to model that, and we have we have a model that can sort of explain the subsidence happening there. And I think it matches the some of the data from the geothermal company on like the extraction rate, like the depth of extraction of geothermal fluids and things like that.
So it's basically anthropogenic, right? It's driven.
Yeah, anthropogenic, and we've also mapped. There's an earthquake that's off the Philippine Fault that's like almost perpendicular to the Philippine Fault in southern Leyte that INSAR was able to show us, and I don't think it's mapped yet in any of the fault maps that we have. But yeah, it's cool that we can see so much of the whole place.
JD, this is a Geo 1 question for you. No? Actually, ako rin di ko na alam yung sagot. But when we teach intro to geology, we say that a fault that moves slowly, like in the case of Leyte, parang creep siya, actually releases its stress and would no longer pose a big danger in terms of forming a big earthquake afterwards. Is still that true? Because what you're saying is that that creep can still result to a big earthquake no greater than magnitude 6.5.
Yes, so I think what we're seeing, especially now with satellite radar, is yung creep, the extent of creep is not homogeneous. So there's a lot of heterogeneity sa behaviors ng faults. So you can have a fault that's creeping pero may locked section ka sa gitna niya actually na maliit lang, which is seismogenic, which could produce earthquakes.
That can still
essentially what we're seeing.
Okay, got it. Okay, so generalization pala yung segment ng Philippine Fault sa Leyte that's just slowly moving, but you see that there are segments there that's actually not moving slowly.
Yes, I think it's mostly because of the limitations ng work nung 90s na syempre yung GPS was still in its early years and we only had a few stations, so we had the generalization was had to be made. But yeah, now with satellite data, we could try and do a project of actually mapping the deformation of the whole Philippines and things like that.
Okay, simulan na yan. Questions from the audience? Meron ba? Otherwise, you can type it naman in our group chat box and direct it straight to our...
Ako may question for me.
Dr. Raimundo, you have a question? Chemistry to, so I guess kay James.
I'm a microbiologist.
Okay, go.
Yeah, and Tatum, I was interested if there are prokaryotes or archaea on the bottom floor, the sea floor, because she said they're only protozoan ones. Are there similar like the ones described by James in the sea floor?
Yeah. Unfortunately, our team was not very involved with the biology team because they're from a different university. So we haven't really interacted since. I sent you a link to more information regarding their research. So maybe you'll find it there. But from what I remember is that with archaic bacteria or with bacteria in general, their task was mostly on testing if they would survive different pressures. So I'm not sure if they actually found during the sampling while they were on the ship or if they were able to get more data after the cruise. So I'm sorry, I wasn't very aware.
It's okay. I'll look at the link. Thank you.
So, CP, may tanong ako kay Nico. I think it's also part of the thread. Hindi ko lang masundan kasi ang bilis ng thread, ang bilis din nila sumagot. So, ano working hypothesis mo for those volcanoes? Are you thinking it's a new kind of volcanism? Are they like shallow hotspots? I think you mentioned something like there might be leaks somewhere, but they're too far from the ridges, really. So what's the overall hypothesis, really, or maybe even alternative hypotheses?
Well, unfortunately, I'm very bad at geochemistry, and the first paper that we're making is more on the geochemical analysis of it. And mainly our conclusion was that it came from the lab, from the lithosphere asthenosphere boundary, and it's mainly pyroxenite in source. That's based on the olivine samples that we got from the geochemistry that we did. But we weren't able to do any tectonic modeling yet, for example. But we are proposing that it is a new type of volcanism, small scale, very localized type. But yeah.
So
but
it is somewhere in the middle, right? Kung ganon, it's not as deep as a hotspot, which could get super deep, right?
Yeah.
These plumes, but it's not quite where magma chambers are in subduction zones either.
Exactly.
Or in the lithosphere.
Yeah. Exactly. There's another research, they call it petit spots. It's near Japan area. And for, we did compare our data with theirs, since it was similar, like it might be related to fractures, it's small scale, but the compositions were very different. So the sources were different and we couldn't really match the stories together. So something localized is probably going on. Yeah.
Thank you.
Okay, very interesting. Any more questions?
Meron din ako kay James CP. Sabi mo, maganda ako para sa kanila lahat.
Sige. Last question for James, and then we
need to move on. I know there's 3 more great talks.
Yeah.
So James, you did the energetic calculations and show that these are the thermodynamically favored processes, and connected that to data. My question really is, it's sort of circular in some way, right? The reactions you put there, we know are enzymatic. We know they're biogeochemical, they're microbe-mediated. But if you take that out of the equation, how do you really distinguish, these processes from abiotic processes purely? Because you can have abiotic methane, you can have abiotic redox processes too. Some of them are really slow in the biosphere without biology, but at geologic timescales, they could be very efficient still.
Yeah. So the reactions that I focus are basically just reactions that are known to be used by microbes because the abiotic processes are very slow. So for example, methanogenesis at very low temperature is abiotically very kinetically inhibited. So that's why microbes take advantage for the methanogenesis reactions as well as
but that's from the perspective of a microbe. But from the perspective of a geologist, when you go thousands to millions of years, it might not be, you might not have to worry about kinetics, right?
Yeah,
but
yeah.
From the perspective of life, it's impossibly long. But from the perspective of geology, it might not be. It's almost instantaneous.
Yeah. So basically, for that application, it's basically, I do these calculations to see what kind of reactions, how do you call it, redox reactions that are favorable in different rock-hosted systems. The way I interpret them, especially just looking at present-day samples, active systems, is basically just looking at which type of metabolism or redox reaction is very favorable in this different rock-hosted systems. However, if we extrapolate the systems to like a planetary scale, so something like that, or a geologic process, so it would be, I would think another question for that example, what type of rock could favor a lot of methane degassing in the geological timescale period? That would be a different way to look at introduced calculations. When you look at water rock interactions as a process itself, like it takes thousands of years or something like that. So, so yeah, it's basically just in framing the questions, and the way that I frame this question is just to use this bioenergetic calculations just to look at active systems. But yes, you can do this kind of calculations, see what reaction is favorable, which reaction is not favorable, at like a geologic time scale, and infer like flux rates basically if we know the rates. So yeah, that's another thing of framing this kind of calculations.
Yeah, CP,
Great.
so we should probably go to the rest of the talks.
Yeah,
But,
yeah. I just wanted to ask one quick question to James. James, after finishing your PhD, what's next for you? Are you doing a postdoc in BSU?
I know I'm waiting for a postdoc. Basically, I'm by fall semester I'll be a postdoc at Columbia University.
In Columbia.
Yeah,
Okay.
so, but yeah, that will be still in fall. I'm still waiting for my employment authorization.
Okay, that's great. Also in the room is Irene Crisologo, who is doing her postdoc also there in the States. Dr. Alisa Alampay is also here. And who else? Boss Vic and everyone else. Okay, so we have 3 more speakers, Bayani. So let's get this moving.